Part 1. How is science done and what is a theory? To start off, we will observe several students participating in an in-class activity to better understand what a theory is for scientists. All of these students are being presented with a Lego structure made up of a few dozen pieces concealed in an opaque cloth bag. They are instructed to build a structure identical to the one inside of the bag, but they are not allowed to look in the bag. Instead, they are only allowed to reach into the bag and feel what pieces go where. They are also given a large amount of Lego pieces, which not only include all of the pieces they need to build the structure, but several other pieces that are not needed. Now that the students have built the structure they believe to be identical to the mystery structure inside of the bag, they are given time to compare their product with their classmates. Although mostly minor differences, some students used a cylinder while others used a Lego head in a particular spot. Additionally, some students used two smaller blocks instead of one larger one in another spot. Lastly, the colors for all of the bricks are different. How can these students resolve their differences? They need to collaborate and get more data. So, they will discuss their differences and reach back into the bag to come to a consensus. After a bit of fine-tuning, the students have the same structure, for the most part. However, the color conundrum has left some scratching their heads. How can they decide on what color is right? Or is that even possible? The answer is that at this present time we cannot know the color for sure. Perhaps at a future time we can develop a new instrument to detect color in the darkness of the bag, but we are stuck for now. These models that the students have built represent scientific theories, and these are based on the best evidence we can gather. So, if this is a theory, then what is a hypothesis? A hypothesis is narrower than a theory. It is a possible explanation for only one phenomenon. For example, when collaborating a few moments ago, some students hypothesized that it was a Lego head instead of a cylinder. Others had less probable hypotheses. The important part isn't what the hypothesis is. However, it is how they gather information to test this hypothesis. And this is what we saw. When the students weren't sure about their own hypotheses, they collaborated, reached back into the bag, gathered more evidence, and refined their model. With repeated testing of many different hypotheses about the various pieces that make up the structure, they were able to create a full structure, which we call a theory. So, how confident are we in a theory? Well, how sure are we of the Lego models? After lots of evidence gathering, repetition, and collaboration, we are pretty sure these Lego models are correct. Maybe we all missed something about the structure, but we are pretty darn sure that we've got this right. The color is probably wrong, but we definitely got the gist of that mystery structure. A scientific theory is the same thing. After lots of evidence gathering, repetition, and collaboration, we are pretty sure our scientific theories are correct. But that is not to say that there isn't more to be learned about them. In the future, we may be able to detect the color of the Lego structure in the bag. And similarly, in the future, a new instrument or the discovery of new evidence may give us a better grasp of our theory. But it is highly unlikely we will ever discover anything that will completely uproot our theory. So I'll repeat, how sure is a theory? Pretty darn sure. Let's talk about evolution for a minute. Evolution is common descent with modification. Common descent just means that all organisms share a common ancestry. Let's break down the descent with modification part. Parents have offspring, and offspring tend to look like their parents, but they are not perfect clones of their parents. There is some variation. Let's say that there's an isolated island in the middle of the Pacific Ocean with a bunch of butterflies. These butterflies range in color from white to red, but the most attractive butterflies are red. If you start off with a few white butterflies, a few pink butterflies, and a few red butterflies on this island, what will happen over time? Look at all these cute butterfly couples. It looks like red and pink butterflies are going to mate more than the white. These poor white butterflies are too ugly for anyone to want to mate with. If every one of these couples had a few butterfly kids, here's what the kids would look like. Now let's say that these butterfly kids grow up and have their own babies. Here are the ugly rejects, and here are the babies from the other couples. Now let's compare the starting butterflies to the butterflies we have now. Look at the color difference. Every generation had kids, descent, that were a bit redder than before, modification. This is evolution, microevolution to be exact. This is the type of evolution that results in the change of gene frequencies in populations over time. Now let's say on the island next door, there's the same group of butterflies, but they don't have the same preference for red butterflies. What will happen over time? Well, this island will stay as a mix of white and red, while this island will get redder and redder. Eventually, these two groups of butterflies may become so different that they cannot mate anymore. A new species has been created. We now have the white-red butterfly and the crimson butterfly. This is an example of macroevolution, or the creation of a new species. We see that microevolution leads to macroevolution. So, to review, a scientific theory is well tested and pretty sure. It's based on the best available evidence we have. Although we could not see into the bag, we could use tools at our disposal to gather information and develop a good theory of what the Lego contraption looked like. Evolution is a theory. Even though we cannot go back in time and watch it happen live, we have lots of data that gives us a good idea of how it happened. Evolution is descent with modification, and it can be divided up into microevolution and macroevolution, two processes on the same continuum.